All right, hello everyone. I'm Robbe Sneyders. I work as a machine learning engineer at ML6, and for the past year I've been working with some other folks on adding Python 3 support to Apache Beam. All right, so why all the hassle? Why did we need to port Beam? So there are three big reasons, and the first and probably most important one is that Python 2 will reach its end of life on January 1st, 2020. So this is only 6 months, so it's actually about time that we reach this state. Also, Python 3 offers quite some improvements, which we will talk on later. And Beam was becoming a blocking dependency for some other projects like TensorFlow Transform and TensorFlow Extended. Now, if you want to port to Python 3, there's actually a guide available on the official Python documentation, so we will follow this guide along the talk. And the first step it mentions is to only worry about supporting Python 2.7 because it is the most compatible version with Python 3. This was already done in Apache Beam, so we could just check this off. And the second point is to have good test coverage. It's always important when you refactor a code base to have good test coverage to catch regressions or any bugs you introduce. And I can't remember the initial state, but currently there are 2,220 Python unit tests and 42 Python integration tests in Beam, and those were a very big help during the porting process. So once this setup is done, the next step is to actually learn the differences between Python 2 and 3. So I've listed some of the biggest changes here. The first one is probably not the most important one, but one of the most known ones. The print statement has become a print function. The next one is that a lot of methods and functions that used to return a list now return iterable objects. This is very useful because we often use them just to iterate over anyway. So this is a helpful improvement. Then one of the bigger changes is the change in comparisons. On Python 2, you could compare almost everything with anything. Like you can see, you can compare integers with strings and even non-types. And this could lead to unexpected behavior. So on Python 3, this was all removed, and you can only compare objects of the same type or if you implement your own comparison operators. On the integer front, we used to have an int and a long type. On Python 3, we only have the int type, but it behaves more like the long type on Python 2. So it doesn't have an upper bound, for instance. And then the biggest and a backward incompatible change is the change to how strings work and how binary and textual data are handled. So we'll look at this a bit more in depth. So on Python 2, we had Unicode and we had 8-bit strings. And these strings weren't always very easy to work with because they can represent two types of data, either binary data or encoded text data. So it's very important to keep track of which kind of data you're working with. These Python 2 strings could also interoperate with other instances of string or other instances of Unicode. And to do this, it used some implicit encoding and decoding under the hood, which again could lead to unexpected behavior. And then finally, a Python 2 string is represented as length 1 8-bit strings. And if you're working in English, this isn't a big problem. But once you start working with non-English text data, this can give quite some issues. We can actually see this on the right side, where I took a string of the word beam with some added accents. And if we take the length of this in Python 2, it returns 6 instead of the 4 that we would expect. Also, if you print a third character, it prints an unknown icon instead of the accented A we would expect. And again, this can be explained if we look at the representation of the string, which contains 6 bytes. So that's the length we get returned. And if you try to print the third element, it's actually trying to print the third byte, which is part of a 2-byte character and cannot be decoded on itself. So as you can see, string manipulation on Python 2 isn't always very straightforward. And there's actually 2 ways to use text data on Python 2, either those strings or Unicode with different behavior. And we should always use Unicode for text data, but of course, a lot of people use string, and then you get to these problems. So this is actually the main reason why Python 3 was introduced as a new major version. It was to solve these problems with the strings. So on Python 3, string is Unicode by default, and we have a very nice mapping of our binary data and our textual data. They both have their own types. Binary data uses bytes, text data uses string, and everything is very straightforward. All right, now that we know the biggest differences, we can actually start porting. And the first step here is to update your code with Futurize. And Futurize is an automatic conversion tool, part of the Python Future package, which calls itself the missing compatibility layer between Python 2 and Python 3. And it focuses mostly on backporting Python 3 behavior. This in contrast to 6, which was previously used by Beam, which focuses a bit more on forwarding the Python 2 behavior. So we chose for this backporting Python 3 because it results in more future-proof code. If we decide to drop Python 2 in the future, then we don't need to port again. But of course, it was a bit more work in the current step. So this automatic Futurize tool, it uses some built-ins that the Python Future package has available. And these are built-ins that have the Python 3 behavior both on Python 2 and Python 3. So now that we know how to port, I could submit my first pull requests. And as you can see, it wasn't perfect from the first time. It took over 100 comments to get my first pull request merged. And this was actually because we had some issues with the approach. And it was mostly with these built-ins from the Future package. So on Python 3, these built-ins are just the regular built-ins, but on Python 2, these are custom classes, and this gave us some trouble. So for instance, we couldn't use those in type checks, only in instance checks, which are slower, and we couldn't use those in some parts of Beam. We had problems with the Cytonization of the code. And finally, it can introduce bugs when you start overwriting types that you're already using. You can imagine if you have a module which uses the Python string type, and you overwrite that string type with some other behavior, that your module behavior might change. So to solve this, we switched to using aliases instead. And you can see that we can get a very nice mapping of our data across Python 2 and Python 3 with this. So for the binary data, we use a bytes alias, which on Python 3 is just a bytes type. On Python 2, it was introduced in Python 2.6 as an alias for the string type to make this compatibility between the versions more easy. And then for text, we use the Unicode alias, which is, again, on Python 2, just a Unicode type. And on Python 3, you can import it from the Future package as an alias for string. All right, so the next step in the guide is to use Pylint and Tox to prevent regressions. So this is also what we did. Beam now has 3 Pylint environments, one for Python 2.7, one for Python 3.5, and one to ensure compatibility between the both. And we added 11 extra Tox environments to run unit tests for Python 3.5, 3.6, and 3.7 against different configurations. And then finally, I want to mention that there was one missing step, big missing step, which is the manual porting effort that was required, especially due to the size and the complexity of the Beam code base. We had to do quite a lot of manual porting, and this is not really covered in the guide. So a status of where we are right now with Python 3 support. So we added it first in version 2.11. And we are currently at version 2.13. So always make sure to use the latest version because we're still working on improving this Python 3 support. Then most of Python 3.5 to 3.7 are ported, except for VCF.io, which might not be ported due to a unmaintained dependency. The type hinting is not enforced on Python 3.6 plus, and then we're still working on Python 3 specific syntax support. And then for Python 2, it will be supported until Python 3 will become the recommended version of Beam. And this is still planned for 2019. But the last version of, with Python 2 support should get updates into 2020. If you want a more extensive overview, there's actually one on the mailing list. And there's a link to it on this slide. So the next step is to start porting your own pipelines. So we already did this for one of our bigger NLP projects. So I want to share a bit of our experiences with you. So some of the things we encountered was we needed to make some small encoding, decoding changes, but if you are already using your string and Unicode correctly on Python 2, these should be pretty trivial and mostly at system boundaries. For instance, the pubsub IO now needs bytes on Python 3. Our sorting broke in some places because of some non-types. So as I mentioned, you could sort these on Python 2. On Python 3, this is not possible, and we actually uncovered some latent bugs with this. So where we were sorting based on a string key, which can be none in some cases, and then the sorting actually didn't work correctly. So this is already an improvement for us by using Python 3. And then finally, we encountered some pickle errors, which are some of the more ugly errors. So pickling has changed a bit between Python 2 and 3. But just as a tip, there are two solutions to solve this. The first one is to make your object pickleable, but this is not always easy if you're using packages from a third party. But the other solution in Beam is to actually instantiate your objects on the worker itself. You can, for instance, use the star bundle functionality, so you don't need to pickle and unpickle your objects. So the good news is that to port our Beam pipelines for this project, we only needed to change 0.5% of our Beam pipeline code. So it was actually pretty easy and fast for us, and I hope it will be the same for you. Thank you.